Okay, today we are going to learn about basic concepts regarding projection of straight lines. Okay, in this first we are going to see the case 1. Okay, so with respect to these cases we are going to learn the basic things about the projection of lines. Okay, so first case 1, it is a line parallel to HP and VP. So in this the line will be parallel to both HP plane and VP plane. Say if I am considering, so this is your vertical plane and horizontal plane. Here our line will be parallel to both HP and parallel to both VP. So this is what the condition. Okay, case 1, it is parallel to HP and parallel to VP. This is vertical plane and this is HP plane. It is parallel to HP and it is parallel to VP. So this is what our condition. So in this so we will deal with the problem. Draw two views of a straight line 60 mm long which is parallel to both HP and VP. Okay, so here you can see that the line, it is parallel to both HP plane and VP plane. Okay, and then they have given the line is the length of line we got to know, it is 60 mm. Okay, so the length of line we have to draw, that is 60, and so it is parallel to both HP and VP plane. Okay, and uh, here we have, so you can see that two views you have to draw, front and top view. Straight line 60 mm which is parallel to both HP and VP. The line is 20 mm above HP and 25 mm in front of VP. So here we are going to use only the first quadrant. So first I am going to draw an XY line here. Okay, so XY VP HP first quadrant. Okay, so the line is 20 mm above HP. So above HP means it is our front view. So here vertically, so here I am marking 20. So this is 20 and 25 mm in front of VP. So in front of VP means it is our top view. So it is 25. So here we have to draw a line of length 60. Okay, so it is parallel means we have to draw a straight line. So from this end 6 boxes we can take, so to 6 boxes here, and here also to draw for 6 boxes. Okay, so this is our line and we can show the dimensions. So this is our top view which is also 60 mm. Okay, so this is our front view. You can name it as B dash, B dash, and this is AB. So this is AB line of length parallel to both vertical plane and HP plane. Okay, we see second case in projection of lines. So the second condition is the line is parallel to VP and perpendicular to VP. So we have to make it parallel to HP and perpendicular to VP. So how to do that? Parallel to VP means here you can see this is our vertical plane, this is horizontal plane. In this condition we have to make it parallel. So you can see here this is parallel to HP. So this pen, it is parallel to HP and it is perpendicular to VP. So perpendicular means you will get a dot here. Okay, you will get a dot on the vertical plane and there is a straight line in the HP plane. So this is what parallel to HP and perpendicular to VP. So like this we have to do. So first we are going to draw an XY line. Okay, XY VP HP first quadrant we are using. Okay, so here the end of the line, so line, it is you see it here, line AB long parallel to HP. We have to make it perpendicular to VP. The line is 20 mm from HP and 30 mm from VP. So 20 mm from HP means it is 20 mm from HP. So 20 mm above HP means it is in the front view. So here, so above HP means here, and 30 mm means here downward. Okay, here you can show the dimensions. So this is 30 and this is 20. So here from this end we have to draw an parallel line. Okay, see this line 60, these 6 boxes. So it is A, B, line of length 60, okay, 60, and here we'll put a dot, that is A dash and B dash. Okay, so this point it is perpendicular and this is parallel. Okay, so this completes the second case. Okay, we see a third case. So third case is line parallel to VP and perpendicular to HP. So how to do this condition? We see it here. So this is our vertical plane and this is horizontal plane. So in this condition here, the line it is parallel to VP, straight line we get it in VP plane, and perpendicular to HP means we get a dot in the HP plane. This is what the condition, parallel to the VP and perpendicular to HP. So like this we have to do. Okay, line of length we have to draw a 50 mm. So here it is parallel to VP and perpendicular to HP. One end of the line it is 20 mm above HP and 20 mm in front of VP. So first we are going to draw an XY line here. So VP, HP and Y. So here both the ends of lines are at a distance of 20. So 20, 20. So we can show the dimensions on one side. Okay, from this end, so here we have to consider 6 boxes. This is A dash, B dash, and we can show the dimension here on one side. It is 60. And here we are going to put a dot. This is AB. Okay, so it is perpendicular to HP and parallel to VP. So this condition also so done. The fourth case, that is line inclined to VP and parallel to HP. Okay, so parallel to HP. So how it is here, you can see this is our VP plane, this is HP plane. So here you can see this is parallel to HP and parallel to VP. So here you can see that this is inclination, we are giving inclination. So whatever the inclinations here, so we will be giving like this. So it is what the inclination to VP. So this inclination to VP, so whatever we give, say this is what the inclination to VP and it is parallel to HP. Okay, so like this we have to do it. So here first I am going to draw an XY line. So VP, HP and Y. So 30 mm above HP and 20 mm. So here we can show the dimensions. Okay, so here it is. So this is 20 and this is 30. So whatever the inclinations we have given inclination to VP, that is we can show it in the VP plane. So sorry, in the HP plane. Inclination to VP, so we have to show it in the HP plane. So inclination to HP, let's say some 45 degree. We will give the angle 45 degree. Okay, here. So here I will take an angle of 45 degree and line of length. So line of length we have to take, that is 50 mm. And here the angle again 45 degree. Okay, this is A, this is B. Now projecting upward, here we get the front view. So this is B dash, B dash. Okay, so this completes the problem. You can see, so this is true length of line. So it is 50. It's 50, right? So if the length of line, if this remains in after projection, say we calling that is true length of line. Okay, true length of line. If the length of line, if it is reduced, okay, after projection, we calling that as an apparent length of line. Okay, apparent length of line. Okay, so true length of line means the length of line will be remain same after projection. So that is true length of line. If the length of line it is get reduced after projection, we calling that as apparent length of line. Okay, so this completes the problem. See a fourth case in projection of line. So line is inclined to HP and parallel to VP. So here we have to give inclination to HP and make sure that line parallel to the VP. So how it is done? So you see it here. So this is vertical plane, this is horizontal plane. Say in this condition it is both parallel to HP and parallel to VP. So now what I'm going to give inclination like this. You can see here. So this is what the parallel to the VP, but here it is nothing but the inclination from the HP plane. Okay, it is inclined to the HP and parallel to the VP. Parallel to the VP means we get a straight line. So inclination to HP means either it is 30 degree, 45 degree, 90 degree. Okay, so this is what the inclination to HP and parallel to VP. So this is how we have to do. So for that, first I'm going to draw XY line and first quadrant. VP, HP, Y. So you can see here the end of the line is 20 mm in front of VP, 30 mm above HP. So 30 mm above HP means here this is 30 and this is 20. So here the end of the line here you have to give the angle here first. It is inclined to HP. So whatever the inclination to HP it is there, it is seen in the front view. Okay, so it is seen in the front view. So here I am going to mark angle 60 degree. Okay, so here I am going to draw a line of length 60. mm line we have to draw. So 1, 2, 3, 4, 5, 6. Okay, 6. So it is having angle of 60 degree, and this is A dash, B dash, and this is the length of 60. So now projecting downward, so we get the length of the line here. So this is our top view, A, B. Okay, so here this is what inclined to the HP, the inclinations to the HP, it is shown in the front view, that is in the vertical plane. Okay, so it is inclined to HP and parallel to VP. So this condition also done. Okay, we see some basic concepts in projection of lines. So as we are solving the problem, we should make sure. So we know that we have true length of line. We know that true length of line in top view, it is exactly equal to the true length of line in front view. Okay, so that is the first concept. And second concept is the true length is always greater than the apparent length. Okay, so be remember it. True lengths are always greater than the apparent length. And then apparent angles are always, which we find out, apparent angles are always greater than the true angles. Okay, this is the one of the difference. So when we are solving the problem, we should make sure the true lengths are always greater than the apparent lengths, and apparent angles are always greater than the true angles. And the true lengths in top view and true lengths in front view, it is always the same. Say true length is given if it is 80 mm in front view, and in the top view also true length is exactly 80 mm. Okay, so that's what. So the basic concepts in projection of lines. This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem, we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first, the end of the line, it is inclined end A. It is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP. So this is 20 and 30. 30 means here. Okay, so we can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. We have to find out the upper end length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first we are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly, you have to mark at 45 degree to VP. And here line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of A, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this, we have to measure this length from here to here. Measuring this length, we have to cut the arc. Okay. So this point, I'm going to give this one as B1. Okay. So where the arc has been cutted, we have to join from here to here. So this is AB. This is AB. The same way from B to vertically upward till locus of A dash. So I will draw a straight line. So this is P2 dash. So by measuring from compass, from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut it. This is A dash, B dash. Okay, so this is nothing but the upper end length. So this A dash, B dash. Okay, upper end length we are going to measure how much it is. Upper end length, it is measuring 57 mm. Okay, so okay, 57 mm upper end length. And this length we are going to measure. This is 67. Okay, 67. Okay, 67. And upper end angles, inclinations also we have to find out. So how much we are getting. So upper end length inclinations, here we have 45 degree. Okay, and this one we have around 50-60 degree. Okay, so we're getting upper end lengths A dash, B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem.